Hello my dear student and learner. We are going to discuss today the concept of a hyperconjugations. We discuss about the conjugations, and conjugation is something related to double bond, single bond and double bond. That is alternative double bond, or we can say double single plus, or we can say double single minus, or we can say double single dot, or we can say double single triple bond. So such type is known as a conjugation. So normally I say that in this type of a structure it involve basically sp2 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 hybridization, but this is a hyperconjugation. So in my terminology I can say this is a high-fi conjugation, so between a sigma bond and a pi bond. Normally conjugation is between the pi bond, but here a conjugations between a sigma and pi bond, so this is known as a high-fi conjugations, that is hyperconjugations. Let us see what is hyperconjugations. So these are the structure. Always I correlate the concept with this hybridizations, that will help us to understand the more reliable. This is sp2, this is also sp2, this is sp3, this is sp2, sorry, sp3, sp2, this is sp3, sp2, this is sp3, this is sp3, this is sp, this is sp, this is sp3. So dear student, if I suggest you, then normally here such type of condition is also observed. So my conclusion and the concept is, if your compound has sp2, sp2, sp2 hybridizations, then it shows the resonance. If your compound has normally sp3, 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 then it show the inductive effect. But if my compound has sp3 and sp2 like this, like this, like this, and also like this, so I can say sp sp3 or sp2 sp3, such condition is observed, then I can say hyperconjugation is possible. So among all the structure, I can say that in this compound there is no hyperconjugations effect. I will show you. From this hybridization we come to the conclusion, if our compound has such type of hybridizations, the compound show the hyperconjugation. Let us go ahead. So in case of electronic displacement in covalent bond, always we think about electronic displacement, polarizations, that is permanent effect, polarizability, temporary effect. This chart also we had seen in a resonance as well as inductive effect, my previous lecture or videos. Among this all, this is, I can say this is due to sp3, 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 this is sp2, 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 and this is sp3 and sp2. So dear student, we have to focus on this only. So today I discuss with you regarding this hyperconjugations. Now what is hyperconjugations? So here if we say, in case of hyperconjugations, this sp3 involves sigma bond, sp2 involve a pi bond. Instead of sp2 you can also take sp also, that also involve the pi bond. So we can say this is a sigma pi bond resonance, or sigma pi conjugation is also the synonyms of hyperconjugations. Okay, let us go. It is delocalizations in inductive effect, displacement in resonance, delocalizations, and here also it is a delocalizations of sigma electron. Here what involve? Sigma electron. So we come to the conclusion that in case of inductive effect, there is no delocalization, displacement of electron. In case of resonance or mesomeric effect or hyperconjugations, there is a delocalizations, but in case of resonance there is a pi bond delocalization, pi bond or pi electron or electron delocalization, and in case of hyperconjugation there is a sigma bond electron delocalizations, right? So normally the sigma electron will delocalized with the unshared p orbital. When there is unshared p orbital, the sigma bond is always with the sp3. I can say sigma bond is always with the sp3, and unshared p orbital is always between sp2 and sp. So normally I have told you that a hyperconjugation is between the sp3 and sp and sp3 sp2, right? So what is the conditions? The condition is at least one alpha hydrogen at a saturated positions or a saturated carbon. I will show you how it is. Alpha to the alkene is sp2, alkyne that is sp3, carbocation that is sp2, carbon free radical that is also a sp2. Carbocation and carbon free radical I will show you in the next video. When the sigma CH bond is separated from this pi system, that we can say sp or sp2 of alkene or vacant p orbitals by the sigma bond, then we can say that there is a bonded pair of CH bond is displaced toward the pi molecular orbital. Let us see here one example. Suppose I have CH, C double bond, CH, H and the CH3, right? I can say this is sp3, this is sp2. So it is very clear between these two the hyperconjugation is possible. I want to show here is a sigma CH bond. So this is, I write the structure in this way also, so you can get the clarity about this concept. So in this structure, I can say this is a sigma CH bond. This is sigma CH bond. This one, sigma CH bond, is separated from this pi system. This is pi system of alkene or vacant p orbital by a sigma bond. So CH bond is separated from this alkene system. Another case we can say CH2H and this is CH2 plus. So in case of alkene, this is clear. In case of vacant p orbital, I can say this structure is very clear about this because this is sp2. So one p orbital is remaining. So in this case only this hyperconjugation is possible. So used to decide the stability of different compound. But before going to that, I want to show you. Suppose I have one compound. This is CH2H, CH double bond CH2. Then CH2H, CH2 plus. Then CH2H, CH2 dot. So here I want to show you this is a sigma CH bond. This is vacant p orbital. Vacant p orbital because sp2 hybridizations. So here if you see that then the sigma bond moves to here. So at that time it will move from that. So what structure we are getting here? We get CH2 H plus double bond CH CH2 and minus. In initial structure total charge is 0, so ultimately this and this total charge is 0. The one more important thing I want to show you is that the H plus is removed from that. So another name of hyperconjugation is no bond resonance. What is the name? No bond resonance, because one of the atom is separated from the system. So here also I can say this will go in these directions, and we get is CH2 double bond CH2 and H plus. Here also due to this it is known as a no bond resonance. Again one electron go in this directions and one electron is going in this directions, and this come at here. So what we get? CH2 double bond CH2 and H dot. So one thing I want to share with you is, if your compound has no charge, that also we had seen in the resonance, the total charge is 0. If your compound is containing the positive charge, then your total displacement containing the plus charge. If your compound has dot, in your resonant hyperconjugating structure also containing the plus charge. So this is I want to show is no bond resonance. Let us go here, and this is known as alpha carbon. This is known as what? Alpha carbon. Alpha to what? This system. This is also known as alpha. Alpha to what? This carbocation. This is alpha. Alpha to what? This free radical. In case of, if you want to see here, CH2H, CH2 and negative charge, there is no hyper conjugations. I can say there is no hyper conjugations, right? So let us go our main presentations. So it is used to decide the stability of alkene, alkyne, carbocation and carbon free radical. These are the three possibilities where we can say a stability can be found. One is alkene, alkyne, carbocations and carbon free radical. Let us go ahead. So how to decide if number of hyperconjugating structure is increase, there is increase a number of alpha hydrogen. So what it indicate? If increase number of alpha hydrogen, then we can say increase number of hyperconjugating structure. If increase hyperconjugating structure, I can say increase a stability. Dear student, I told you that the stability of alkene is mostly decided by a hyperconjugation. Again, I told you stability of alkene is mostly decided by hyperconjugation. Let us go ahead. These are the two structures. So I want to clarify a hybridization. This is sp3, sp3, sp2, sp2. This is sp3. This is sp3. Let us see here also. This is sp3. This is sp3. sp3. This is sp3. sp3. sp2 and sp2. So if I see here, then I have to decide whether hyperconjugation is possible or not. Yes, the hyperconjugation is possible between this group, and hyperconjugation is also possible between this group. Yes. So here also hyperconjugation is possible between this two and between this two. Now I have to decide which is more stable. Then both have hyperconjugations. I have to decide which containing more number of hyperconjugating structure. So here this is alpha carbon, this is alpha carbon, this is alpha carbon and this is alpha carbon. So alpha to what? Alpha to this alkene system. So this containing 3 hydrogen at here, this containing 3 hydrogen at here, this is 2 and this is also 2. So total 3 plus 3 6 plus 2 8 plus 2 10 alpha hydrogen. Saturated positions, saturated position, because saturated position is required, otherwise it goes to the resonance. Here this containing 2 electron, this also containing 2 electron, this containing 1 electron. So among this we see there is 5 alpha hydrogen at a saturated positions. I told you that increase number of alpha hydrogen, increase hyperconjugating structure, then increase stability. So I conclude that this is a more stable alkene. This is a more stable alkene. Let us go ahead. Now dear student, I told you that directly we comes to the conclusion all the containing 1 alpha hydrogen. So I want to show you here number of alpha hydrogen and number of alpha hydrogen is there. So this is the case 3, 3, 2 and 2. So I can say 3 plus 3 6 plus 4, so 10 electron. 10 alpha hydrogen, sorry, not electron, 10 alpha hydrogen. So here 2, this is 1, there is no alpha hydrogen. So I can say 3 alpha hydrogen. Here this is 2, this is 3, this is 1, 6 alpha hydrogen. Here 2 and this is 2, so we can say 4 alpha hydrogen. Normal concept is increase alpha hydrogen, increase stability. So I can say this is more stable and this is a least stable. This is a least stable and this is a more stable structure among the given alkene. Let us see here also another example, all containing 1 sigma bond. So this is alpha, this is alpha, this is alpha, this is alpha, alpha, this alpha, this is 2 are the alpha, this is an alpha, this is an alpha. If we see here, then I can say that it containing 7 alpha hydrogen, then it containing 8 alpha hydrogen, then it containing 3 alpha hydrogen, 3 alpha hydrogen. Now you can also say that which is more stable, those who have a more number of alpha hydrogen. So this is a more stable structure, this is a most stable among the given structure, this is a most stable. Now which is least stable? This is least stable. Why? Because it containing less number of alpha hydrogen, least stable. Okay, let us come ahead. So this is the structure. I can say this is sp3, sorry, sp2, 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 sp2 and sp3. This is sp2, sp2, sp3, sp2, sp2, sp3. This is sp2, sp, sp2, sp3 and sp3. Which is most stable? Diene. When, dear student, there is diene, the concept of resonance can also come. If you see in all the structure, this is the case, sp2, sp2, sp2 and sp2. In my resonance video, I told you that the structure has sp2, sp2, sp2 and resonance is predominating among this all. So priorities are aromaticity. First we have to see aromatic, then we have to see resonance or mesomeric effect, then we have to see hyperconjugations, then we have to see a inductive effect. So if the resonance is there, always it is more stable. So I can say this is a more stable. So that is, if you see here, this is sp3, sp2, sp2, sp2 and sp2. So there is no resonance. In this two structure, there is resonance. Among these two structure, if you see, it containing, this is alpha, this is alpha, this is alpha. In this case, these two are the alpha. So there is 3 alpha hydrogen. And in case of this one, there is 3 plus 2 plus 2, 7 alpha hydrogen. So both the structure containing resonance, so we cannot conclude anything from the resonance, so we have to move to the hyperconjugations. So in case of hyperconjugation, both the containing the hyperconjugation, but hyperconjugating structure of this one is higher. So this is a most stable diene among given. Most stable dienes. Let us go ahead. Stability of alkene. First, we have to compare between these three. And then we have to compare about these three. So let us see what happened to this one. So this both containing 1 alpha hydrogen. So I can say among this 1 alpha hydrogen is there, sorry, single bond is there. तो हमें क्या देखना होता है? अल्फा हाइड्रोजन. So इसमें कितना है? 3 plus 3 plus 3 plus 3. So 12 alpha hydrogen is there. So that is a 12 alpha hydrogen. Nearby the structure, how many alpha hydrogen? 9 alpha hydrogen. How many in this case? 6 alpha hydrogen. So dear student, I can say this is more stable than this one. What about this? There is no alpha hydrogen. Very good. So there is no hyperconjugations. Here 3 alpha hydrogen. Here 6 alpha hydrogen. So I can say this is more stable, and after in that case. So stability of alkene is mostly decided by hyperconjugation, but stability of diene is decided by, so here I can say alkene and alkadiene. So that means diene. Alkene is decided by hyperconjugation only. Hyperconjugation only. And in case of alkadiene, we have to decide the resonance as well as after that hyperconjugations. Okay, so this is required to understand. So these are the basic of stability. So I give you one idea about that. Stability of alkene and stability of alkene is indirectly proportional to heat of hydrogenations. This is just to remember it, it helps to you. So I can say in case of stability of alkene, so normally I can say you have to draw a frog like this. This is a stable alkene. After that, this is another one. After that, we have this structure. Then we have this structure. Then we have this structure. Then we have this structure, and this is one. So always stability follow in these directions. Stability is always follow in this direction because it containing a 12 alpha hydrogen. It containing a 9 alpha hydrogen. It containing a 6 alpha hydrogen. It also containing 6 alpha hydrogen. It also containing 6 alpha hydrogen. It's also containing 3 alpha hydrogen. There is 0 alpha hydrogen. So increase alpha hydrogen, increase a stability. But dear student, you may have the confusion regarding this. But for that, you have to continue with my video. I told you that between these two you may clarify. This is trans, and trans is always a stable structure compared to the cis in case of alkene. But what about this? For that you must have to see a continuous video of reactions of organic and carbocation that I will explain in a later on. So let us go and see. I hope you enjoyed today's video and find a concept of a hyperconjugation. If you have any doubt, you may write in a comment box in a YouTube. And if you like that, then please, to get update, continue with us. Thank you. Thanks a lot.